Hi everyone, in this video we talk about the distributive law. The concept actually here is that what happens when you mix union with intersection, and it works exactly like basic algebra where multiplication distributes over addition. So if we have this x times between brackets y plus z, we get x times y plus x times z. So that's what happened exactly. The first rule is intersection over the union. So A inter C union B is actually A inter B union A inter C. So this is the first law or the first rule, and let's prove this rule before going to the second rule. So why this happens? Actually, to prove this rule we must prove two things here. So we must prove that from left to the right, that this subset of this, and from the right to the left, which means this is a subset of this. So this is the rule we learned in the first videos. So we know that if B is a subset of A, that means the intersection of B and A is B and their union is A. Now let's prove from the left to the right. So let x belongs to our right left side. So A belongs to this. What does this mean? It means x is in A and at the same time it is in B or in C. So here we have two cases. Either x is, we know it is in A in all cases, but for between B and C, either it is in B or C. So if it is in B, that means x is in A and B because it is in A in all cases. But if it is not in B, if x is not in B, that means it is in C because we said it is in B or C. If it is in C, that means it is in A and C. We have this. So x is in A and B or in A and C. And exactly that's what we want here. So the first is a subset of this. So whatever x in this part, we find it also here, which means this is proved. Now let's prove it from the right to the left, which means now we assume that x is in this part here. If x is in A inter B union A inter C, that means x is in A and x is in B, or this is or x is in A and x is in C. Again, here we have two different cases. So either x is in A inter B, which means it is in A and B. In this case, if it is in A and B, so x is in A inter B union C. Why? Because simply if x is in B, it is also in B union C. Okay? If x belongs to B, that means x is also, it belongs also to B union any set. Okay, so we can, instead of B here, instead of B, we can add any set to B here. So B union C. Instead of B, we write B union C because it's the same thing. If X is in B, so it is in B union anything. Here we need C, so we put C here. And also the second case here is if X is not in A inter B, so it means it is in A inter C. So in this case, it is in A inter C. C here we replace it with C union anything, but here we need to put B. So it is A inter C union B, which is the same thing. In the end, we got that X belongs to A inter B union C, and we proved this from the right to the left. So this is also proved. So since the left side is a subset of the right and the right side is the subset of the left, this proves the equivalence. That means the left side equals the right side. This is for the first rule of the distributive law. So whenever you see this, you can convert it to this, or if you need, whenever you see this, you convert it to this. Now let's see the second rule, which is the union over the intersection. So here, if we have A union B inter C, we can also do the same as we did with the intersection over the union. So A union B inter A union C, inter A union C. So how to prove it? We do the same thing. So we prove from left to right, then from right to left. Let's start with the first part, so from the left to the right. So let's take X, which is in this part. So it is in A union B inter C. So if X is here, that means it is in A or it is in X and C together. So we get two cases. Either X is in A. If X is in A, that means it is in A union any set. Here any set can be B. So if X is in A, it means it is in A union B. And also it is in A union, we said any set. Let's take C here. So this and becomes the inter. So if X is in A, it means X is in A union B inter A union C. Now let's see the second case. So if it's not in A, automatically we will find it in B and in C together. If X is in B and it is in C, that means it is in B union any set, let's say A, and it is in C union any set, let's say A again. So we get this in both cases. If X is in A or in B and inter C, we get this. It is, so our X is in A union B inter A union C, which is proving this. That's the first case from left to the right. So any X that belongs to this, it must belong to this. Now let's see the from the right to the left. We try to prove this from here to here. Let's see if this is true. So from right to left, let's let X belongs to this. Let X is here. What does this mean? So this means if x belongs to this, that means x belongs to A or x belongs to B, and also x belongs to A or x belongs to C. Here we get again two cases, either x in A or x is not in A. If x is in A, that means it is in A union any set including B inter C. So it is here. Now if it's not in A, that means it is in B and C. That's what this condition says. Okay, so if it's not in A, that means it is in B and it is in C. And if it is in B and C, so it is in B and C union any set, anything, you can add anything here, so it is union A. This is the same thing. In the end we get this. So we proved again that the left side is the subset of the the right side is the subset of the left side. So this is our final formula. So whenever you see this, you can convert it to this or the opposite. Like if you see this and you need to get this, you can convert it because they are equivalent. So thank you for watching and see you in the next video.